Hello. So, good mornings to all of you. My sound is audible and screen is visible. Hello. Okay, thank you. Good morning to all of you once again. So, just we'll go for revisions of yesterday's flow process charts, and after this, next two charts will be there. That is two under process charts and multiple activity charts. So yesterday we have seen one job that jobs manufacturing on the CNC and VMC machines, and what is actually flow of the materials from the bend saw machines to last finished product. So whatever description of activities are there, it is written one by one. Then how much distance made by that materials and how much time taken to move that distance, it is shown on this table. And here's we have used this all five symbols. Previously we have seen uh, the manufacturing of this gear blank by using our CNC and VMC machine. Yesterday we have seen drawing as well as jobs, and after this same jobs, if we purchase the raw material for manufacturing same job, so from our outside the suppliers to the last stage of VMC machines, in which way that material flow. So that diagrams it is shown on this blackboard. This is called flow process chart. Flow process charts means movement of the material from one stations to the next stations. So related to our the jobs, first of all, to bring the bars from the outside. After that, cutting bars on hexa. So cutting is the operations to bring the bars from the outside. This is the transportations. Inspection of the bars, bring to drilling machines. The transportation is there. Delay for waiting first job is completed or not. Then drilling, bring to CNC machines, and there's operations are there. CNC machines. After that, inspections. After this, same jobs we can perform on the VMC machines, and after that inspection, and then we'll put these jobs in the store. Okay, so like this flow movement is shown. So you can see at the right side the symbols we have used here. Operation. So these graphical representations, what actually we will get from this graphical representation? Is it possible to reduce certain movement of jobs? Is it possible to reduce some movement of job, unnecessary movement, the delay, operations? So through these charts, definitely you will get idea about your job. So this is the most important flow process charts in industry. Very simple charts is there. Every jobs you can make this flow process chart. Flow process charts means in which way the material will flow from cutting section or from the store to the stock of the finished product. So how, in which way material will flow? In some place operation will be there, some place inspection will be there, some place transportations will be there. Because of some unavoidable problems, delay will be there, and after this you can submit the jobs in the stores, or after that dispatch will be there. So this is about the flow process chart. Now next we'll go for two-handed process charts. So next chart, that is the two-handed process chart. So once again, I will revise the two charts. It comes under the method study. First chart, that is the process charts. So what it contains in process charts? So only two symbols we can use. One is the operation symbols and second is inspection. Only operation and inspection, these two part and related timing you have to note down. Yesterday, how we can manufacture the gear blanks, I have shown that jobs and related the operation on CNC and VMC machine. For this purpose, we have made this is a practical examples in our workshop, and similar types of example you will have to see in industry also. After this, for same job, if we purchase the raw materials and if we start our production, how the flow process charts will looks. So it is looks like this, which actually we have shown on the blackboards. Okay, so in which way the material will flow uh, while flowing this material from the transportation stations to the last part, that is finished part. Okay, so here we have used five symbols and related timings we have noted, and if you make the total times of this, okay, so if you make the total times of this, then you can write here the total time. So whatever the total times you will get, this is about the existing methods. Now, what is our main motto? How we can reduce these total times by reducing unnecessary movement, the unnecessary inspections, unnecessary transportations, the unnecessary delay. In this way, we can reduce the time. This is the main motto of the flow process chart. So, flow process chart only we can use for movement of the materials. Okay, and process charts only operation and inspection. So here you have to remember the difference between the flow process charts and operation process charts. Okay, operation process chart, this is also called outline process charts or bird's eyes. Only outline we can see, and flow process are flow of the material from one place to the next place. So unnecessary transportation, inspection, all these things we have to reduce after the graphical representation. And this is actually things actually we requires in industry, because main motto in method study, unnecessary things, the unnecessary cost, unnecessary delay, that we have to reduce. This is the main motto. Okay. Now we go to the next part, that is the 200 process charts. So next charts, this is the 200 process charts. 200 means we can use our two hand for operation purpose, left hand side and right hand side. Okay, so descriptions of the activity and all the symbols we can use here. Okay, so when we can use this 200 process chart, whenever repetitive action is there. Repetitive actions means assembly of carburetors, assembly of nut bolts, okay, washers. So whenever a repetitive things are there in industry, always we have to use these 200 process charts, means left hand side and right hand side. So at a times, two hands we can use for operation purpose, assembly purpose. Not a single hand will work. We can use both hands for working so that efficiency, effectiveness will get increased. So here's we'll take one example, the assembly of nut washers over the bolts. So examples I will give here. Example. Okay. So one example is the assembly of a nut, washer, and bolt. Okay. So these 200 process chart, see that two hands are there, and here is the workstation. Okay. So ergonomically, you can design the workstation as per this movement. So around these 500 mm, the workplace would be there, and here is actually the workstation, and here is the nut, then the washers and bolt is there. Three trays are there. So how we can make the assembly? Okay. So we'll take the washer, we'll take the nuts, and after that we can take the bolts and go for assembly. Okay, correct. Otherwise, many times in industry, in what way they are doing, they are taking the one hand gold, one hand washer like this. So here we can use the two hands for assembly purpose, not single hands. Sometimes we are using our right hand for assembly purpose for doing any works. But it is not like that way. We can use both hands for doing works. Okay, and unnecessary motions, the idleness of one of the hands, we can reduce this and ask to that worker you can make like this. Okay, so in this way, how we can make the charts? I will show this. So this side left hand. Left hand. Here is the so that we get number. Here is the right hand side. Right hand See that. So here's I have made the structure of two-handed process charts. So here is the example of nut, washer, and bolt. Means we are making the assembly of nut, washer, and bolt with help of two hands, left hand and right hand. So chart is like this. Left hand symbols. Here I have used the three symbols: round operation, arrow transportation, and triangles, that is the store. Okay. Activities are there by right hand side and left hand side. So what is the first activity that I will write here? The first activity uh, to the bolt tray means our left hand uh, will go to the bolt tray. At the same time, our right hand it will go to the washer tray. Okay. Bolt tray. And here go to washer tray. So here three trays are there. In one tray, bolt is there. Next tray, washer is there, and third tray, bolt is there. So, nut, bolt, washer, three trays are there. So, first of all, I will show with help of body language. See this. Here is the two hands, and here is the workstation. This side bolt, this side washer, and here is the nut. Or you can change this one. So at a times you can go like this way, bring together like this way, and go for us. Like this way and go for us. You do not do like this. One for searching the like this, like this. It is not allowable. Because of this, efficiency of the assembly, effectiveness will decrease, more time will required for the assembly. This is the study made by the our FW Taylor scientist related to method study. So here's first go to the bolt tray, left hand. At the same time, our right hand will go to the washer tray. So here is the transportation movement is there. So transportation movement, you can put their dot. So for this point, you can put their dot. Similarly for this, you can put their dot. This transportation movement is there, and at the bottom there is the time scale. So there is actually time scale. Time scale maybe in minutes or milliseconds. So time scale always be at the bottom of the charts. Time scale should be at the bottom of the chart. Okay. So this is the first activity done by left hand and right hand. Now I will write second activity, pick one bolt. Second activity, pick so you pick up one bolt. Second activity, one more. So pick up. So this is the operations. Pick up. This is the operations. You can make this point in that corresponding symbols this column. Okay. So here's a pickup bolt. Here is the operation. Pick up the bolt. This is the operation. Here also. This is the two operation. Two operation. Correct. Two operation is worse. Then we will go to the returns to the original positions. Returns to the original positions means again transportation. So third point returns to the original positions. Returns to the transportation is there. Returns to the original positions. So that while picking bolt, pick up the bolt. Initially, this is the transportation. Pick up the bolt and washer and returns to the original. Returns again, it is the transportation. Then this is the okay. Now we'll go to the fourth activity, that is holding the bolt and assembly the washer over the bolt. Holding the bolt. Fourth, that is holding. Hold, hold, and assembly washer over the bolt. Fourth activity. Fourth activity. Hold and assembly over the washer. So bolt it will hold like this and put here washer or tightening. So this is our fourth operation. So so this is the holding bolt, this is the delay, and assembly, this is the operations. So here, hold the bolt, this is the delay, and assembly over the washer, this is the operation. Okay, over the operation. Now, fifth, that is the ideals, fifth, sixth, seventh, eighth. After that, to the nut tray, pick up the nut, and this is original assembly bolt. Now, here's right hand side. Now we have only bolt and washer. We have only bolt and washer up till now, but nut is required. Okay. So both hand we cannot use to pick up the nut. Okay. So at this time, our one hand, so right hand, it will go to the that nut tray, pick up that nut, come to the original position. Okay. And assembly for this. So this is the operation only for right hand side. At the same time, left hand side remain idle. So let us we write the next the activity related to nut. Up till now in the charts we have seen only the activity related to bolt and washers by using our two hands. Now we go for nut. So this operation, go to nut. Go to nut means transportation operation. One six operation pick up, one six operation pick up, one. So this operation. 5, 6, 7, 8. So what about the left hand side? Say that when in fifth serial numbers, our right hand will go to the tray of the nut. This is the transportation. Then pick up the net, operation will be there. Then returns to the original positions. This is transportation. Assembly of nut over the bolt. This is the operation. So within this time, our left hand side remain ideal. So left hands remain ideal. So here all these parts remain ideal. Ideal. So this symbol is here for ideal. Ideal. So ideals means triangles will be there. Ideals will be triangles will be there. After this, our ninth to the assembly tray, and after this we go to the next operation. The assembly of nut bolt is over. Now assembly of bolt nut washer is there. Ninth operations to the assembly tray. To the assembly tray on left hand side. Assembly tray. Assembly tray. So here is the transportation system. And then put the bolt in the tray. This is the transportation. Operation is one. Return to the original. And then return to the original. At this time, so whenever the assembly is this, then we have to make the representation of movement of our right hand side and left hand side. Now I will join this dot. So this dot will be there. And related to this, say that I made this lining. Now you can see the work of right hand side and work of left hand side. Uh, by this graphical presentation, it shows that there is no equal work given to each hand. Now, is it possible to make equal works to both hands? That we have to get it searched through this 200 process charts. Actually, as per standard study, it is expected to give equal effort to both hands. But this graphical presentation in the assembly of nut bolt washers, it shows that sometimes uh, this presentations sometimes left hand side remain ideals and sometimes right hand side remain ideals. Okay, so it should not be there. We can make use of both hands for the assembly purpose, then and then working efficiency, effectiveness of the work, cost reduction will be there, downtimes will get reduced. This it indicates the 200 process charts. Okay, so and when we can use this type of charts whenever repetitive works is there in industry. Repetitive work means assembly is actually repetitive work. So whenever these repetitive works come into pictures in industry, always we have to use this 200 procedure. One example in automobile industry, assembly of carburetors. You can see the how the assembly of carburetors, assembly of the small IC engines, assembly of our watch assembly. It is a best example for a two-handed process chart because we are using two hand for the assembly of watch, big watch, our hand watch or the wall watch, whatever the assembly we are doing. So that assembly study we can uh, make with help of two-handed process chart. And at the bottom there is a time scale. Means each activity, how much time is there, that you have to note down. And from these things, it will come to know that how much time taken by left hand side, how much time taken by right hand side. Okay, and from this we can judge how much time which one hand is remain ideal. Is it possible to reduce this idle movement, or is it possible to give equal effort to left hand and right hand side? That things you have to search with the charts. Okay, so this is about the two-handed process charts. So up till now from yesterday, we have completed three charts. First chart, that is the outline process charts. It is called operation process chart. It is also called eyes, bird's eyes. So three name is there, and these process charts we are using two symbol only, operation symbols and inspection. Only two things has been recorded. One is the operation and second is inspection. Make charts at the morning also we have seen, and yesterday also we have seen, and practically examples already I have given to you yesterday related to the gear blank which is manufacturing in our workshops with help of CNC and VMC machines. Whenever you will come to college, you can also visit to our this production center. You can make the study and try to reduce the idle times also. Same things you will have to do in the industry. So next our flow process chart is there. Flow process chart, when we can use the flow process chart? Whenever there is a movement of jobs along with the operations. Okay, along with the operation, along with the delay. So once the materials, if we demand from the market, it will comes to our workshop premises or industrial premises. After that, hex or bend saw cutting will be there, operation will be there. So after that, that material it will goes to the machining section. Transportation is there. Their operation will take place. After that, inspections will be there. Some of the machines that material will get wet because the one more job is going in that machine, and once the job that job's turn is over, the hour jobs will be there, and once all the jobs will get over. It will go to the godowns or stock unit as finished, and it is ready for dispatching. So for this purpose, we can use the flow process chart. And 200 process chart, example, nut, bolt, washer assembly is there. Three trays are there. One tray nut, one tray washer, and one tray bolt is there. Now, how we can make the assembly at a time with both hand? We can take the bolt and washers. After that, you can go for nut, and it is not standards. You can make your minds to draw like this way. Actually, you have to do these practically things and decide this. Yeah, how much the time each hand and how much time the one of these two hands will remain idle. So idle, these idle times we have to reduce. Equal efforts we have to give for both hands, and because of this psychological fatigue will not develop to that worker. Otherwise, fatigue will get develops to one of the hand, and this is the effect on the efficiency of the worker. So when we can use this 200 processor, whenever repetitive work is there, whenever assembly is there, nut bolt assembly, carburetor assembly, hand watch, this your wall watch, hand watch, or any other watch assembly, it comes under the 200 process. Just you have to remember whenever the assembly part is there, always in assembly part, repetitive activities are there. So you can remember the example of assembly of our watch. Wall watch is there, hand watch is there, carburetor assembly is there, IC engine small assembly is there. Okay, gearbox assembly is there. Then your chain assembly is there. Okay, so you can take any examples related to assembly, because in assembly repetitive activities are there. So in your gate exams or in your these objective type of questions, the questions related to this, then we can use the 200 process chart. We can use this 200 process charts only repetitive activity, and where this repetitive activity will occurs only in the assembly, and you can remember the different types of assembly. I have given example of carburetors. The watch example is there. Then nut bolt assembly is there. Chain assembly is there. So whenever assembly part is there, we have to use this 200 processor. And flow, whenever movement is there, flow. And whenever operation and inspection is there, we can use the process chart. Okay. So this is about the 200 process chart. So anybody having any problems related to this, you can ask. Any problems related to 200 process charts? Hello? Any questions? Otherwise, we will go to the next chart, that is the multiple activity charts. Hello? Multiple activity charts. Next chart is there. But before that, anybody having any doubt, these things not able to understand, you can ask the questions to me. Hello? Shall I proceed? Shall I go to the next charts? Just give response from your side. Okay, thank you. So we'll go to the next charts, that is our multiple activity charts. So next charts, that is our multiple activity charts. So multiple activity charts means what? One man handling more than one machine. Once again, our this workshop examples, we have the CNC, VMC, and other lathe machine also. So we are here doing the production of the gear blanks. Okay, and initially we are getting the raw material from the industry. First step uh, is the drilling that materials on our conventional machines. After that, uh, we have to make use of CNC machines for boring of the same materials. Once the boring facing step turning is worse, then we'll send these materials to the VMC machines for drilling purpose, and the jobs will get over. And all this activity is done by one man. Okay, means one man is handling two machine. It comes under multiple, or more than two also. Means more than one always. Machines are there. If it is handled by the any workers, then it will come multiple activity chart. Okay, so multiple activity charts. In the charts, we will see the first man machine charts. Correct. In this man equipment chart is there, man material chart is there, machine material chart is there. So out of this, we'll take one example, man machine chart. So under this, we take man machine chart. Means one man is handling two machines, like this examples will take. And these charts activities more than one worker or machines are recorded, activities recorded on common time scale. See that always bottom there is a time scale. It is used when worker operate number of machines at a time. Activity of workers are recorded in separate vertical columns. So that activity will going to see. So here's examples of our VMC and CNC machines. Okay. So here's the activities and operators and the machine one and machine two. Okay, so let us see the man machine chart. Activities. Okay, so I will take example of yesterday. We have seen the example of our job. So see that yesterday we have seen our this job. This is our job manufactured by two machines, CNC and VMC. So this part, boring, step turning, pacing, and this is the turning, and these holes are uh, drilled by VMC machines having 82 PCD and 7 mm. So PCD is 82. P circle diameter of this hole is 82. Diameter of the hole is 7. And for this we have made the jig on the VMC. So and this total jobs, this is manufactured on both machines by one man. You can come and see our workshop. This is manufactured by one man. Jigs picture, if it is available with us, the same jobs we can manufacture in our workshop. Okay. Now, so here I will show the certain symbol. You can make it this left side. Here, so our left hand side activity symbols. Loading purpose, which symbols we can use. Machining purpose, which symbol we can use. Unloading purpose means we have to fit our job on the machine. Machine will perform its operations. After that, we'll remove. After that, we'll put the next job. Loading will be there. Okay. So you can write the activity by one, and after this, you can go for mm, next one. So here's initially the loading to first machine. So initial operations, you can see this. The first this ID and the facing and step turning we'll have to do on the CNC machine. So first operations, so we related to turning, facing and step turning. So here's the activity, facing, turning, going, going. So in order to do these things, what the operator will do, that operator will work and big symbol, loading symbol will be there. So within this activity, we can make use of loading symbol. This symbol, loading. Usually we have to for this, if you write there, can same if you have to do this, you have to holding, holding jobs. Means loading. We have to put a job on the check of this particular machine. Okay. So this is the loading jobs. After this, the loading machining will take place. Once the machining will get over, we have to remove unloading will be there. So after this time, VMC remains ideal, no? So ideal symbol will be blank. So here I will add here Idle remains like this. Nothing is there. So at this time, this is the idle. VMC will remain idle. And the corresponding time is here. Corresponding time. When we are loading our job on CNC machine, VMC remains idle. Operator is doing only that work. Correct? Operator is doing only that work. So after this machining will start, no? So next the activity that is the machining. Machining. Once the machining will be there, whether this will operator will not do anything, he will ideally go to the next machine. So the machining will be there. Okay, once the machining is going on at this time, this operator will do the work for this. Loading will be there from BMC because already one job is over. Okay. So at these times, first machining is there. If it is going on, then we can go for loading. Loading on the VMC. Here, this is the loading, machining, and this is done by this operator. Okay. Once he will hold the job, this will remain idle. And once machining will start, this operator will do this to the loading. So there is the loading. So this is the loading, there is the loading, and here is the machining. Machining is there. So once the jobs will get loads, once the job will get loads, means our VMC machine loading is there. Once the machinings will get over, then we have to go for unload. Unload. Okay, unloading. Any time here we can write here. Unloading. Unloading 5 minutes. What is the symbol of unloading? This one. So here, at the same time, the BMC, the machine is going. At the same time, machining is going on. And related times you have to write that. Okay. So CNC and VMC, loading and unloading, that you have to count. So total times related to CNC, related to VMC, you have to get it through the job. And whenever idle is there, that idleness we can. And this once again it will go for. Once this operation is worked, we have to remove the job. Once the operation is over, then we have to go for unloading, unloading, and after this unloading, this will remain idle because one man is doing one. So like this way, you have to do this work. Okay. So the one operator can handle two machines along with some activity and times. So from this total times you will get times related to CNC, time related to VNC, also separate you will get. And this ideal, how much time CNC will remain idle, how much times VMC will remain idle, what is the machining times for VMC, what is the machining time for CNC from this we will calculate. Okay, so multiple activity means one worker handles at least two machines or more than two machines. Okay, I think our time is over. So next lectures we're going to repeat this multiple activity and then we'll go to the next chart or diagram. Okay. Thanks to all of you once again.